number 4, let me make this bigger so we can see everything. It just says the sample space for rolling rolling 2 fair die is shown in the accompanying table. We want to reproduce the table, but we want to replace each of the 36 equally likely ordered pairs with the corresponding sum for the 2 dice. Find the probability of rolling each sum. Complete parts A through K below. Okay, so they give us a little table here. Can we move it and have them both? Can I move that? Yeah. Okay, so I can't shrink this down. Let me just get one from the web. That will be a little bit better. And I'm not going to be able to get it all up unless I shrink the screen. Okay, so maybe I can do it now. Okay, so I have to make things smaller. But when they say the sum, you're going to be adding up the pair. So this is rolling a 1 and a 1. If you add 1 and 1, you get 2. And then as you just go across, it's adding 1. So 3, 4, 5, 6, 7. All right, when you get to the next row, that's the 2 and the 1. So now we're starting at 3. So what you'll notice, there's a pattern. Whatever number you start with here, it just goes 1, add 1 across. And it's also going to do the same thing going down. So 2, 3, 4, 5, etc. Because it's this number plus 1. All right, so I'm just going to do this really quick. 3, 4, 5, 6, 7, 8. And then we start at 4, 5, 6, 7, 8, 9. And then we start 5, 6, 7, 8, 9, 10. And then we start 6, 7, 8, 9, 10, 11. And then we start 7, 8, 9, 10, 11, 12. Okay, so this is the sum that you get when you add the 2 dice up. Okay, so we can close that out now that we're done. So we're going to be using this to answer the following questions. The probability of rolling a 2. So the only one that has a sum of 2 is 1 and 1. And we already told that there were 36 outcomes. So there's 1 out of 36. Part B, find the probability of rolling a 3. All right, so rolling a 3, there's 2 3s out of 36. A little bit easier to see. All right, so 2 3s out of 36. 2 out of 36. And since both of these are even, we can divide by 2. And that will reduce to 1 out of 18. Okay. I guess I could have wrote this probability of 3, so we know what we're looking at is 1 out of 18. This helps us remember what we answered or what we were trying to find based on this table here. All right, probability of rolling a 4. Now, here's also something that you can notice. Let me make this big. All right, so as you go across the table and you see a number, that number is repeated down the diagonal. So 4 is all the way down the diagonal. When you get to 5 on the first row, it's all the way down the diagonal. 6 all the way across, and even 7. And if you are familiar with the game of dice and people have played craps and different things, the number 7 is highly sought out. And as you can see, the number that sums 7, or the number of combinations that sum 7, there are 1, 2, 3, 4, 5, 6. That's the highest number compared to any other number on the board. 7 occurs more often than any number. 6 would be right below it with 5, and then 8 is also high with 5, but 7 occurs the most. That's why in the dice game, craps, and other games, that 7 is a sought out number because it's the highest probable number. So we're going to look at the probability of all these numbers. Let me go ahead and make a scale because we have A through K. So let me show you how this is working. I normally make a table, and we'll be able to fill this in pretty quick. So X is the number that we're looking for. Probability of X is the probability of that number. And this is what we call a probability distribution if you go a little bit further into probability. The numbers we get are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right. And there goes in a pattern. There was 1 out of 36, and then there was 2 out of 36, 3 out of 36, which we'll see, and then 4, 5 out of 36. It was 6 out of 36, and then once you get there, it starts going back down. So it counts all the way up to 6, and it starts going back down. 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, and 1 out of 36. And then the ones that can be reduced, we must reduce them. So 2 out of 36 will reduce to 1 out of 18. Okay, so this is the one we want. 3 out of 36, both of those are divisible by 3, so 1 out of 12 is what we'll actually put in here. 4 out of 36 can reduce to 1 out of 9, so we want a ninth. 5 out of 36 is that number, and then here we get 1/6. When you divide both by 6, 5 will not reduce. 4 was 1 over 9. 1 over 9 divided by 4. This is 36, looks like a 39. This is 1 out of 12. And this is 1 out of 18. So they're going to ask us all of these, but that is the pattern. Again, you can verify that if you look at this and check. 1, 2, 3, 4 5s, 5 6s, 7 6 7s, and then when you get here, you go back down to 5 8s, 4 9s, 3 10s, 2 11s, 1 12. So we're going to input all of these probabilities now because that's what all these parts are going to be asking. So now that we have them, 4 right here is 1/12. So probability again to 4, 3 out of 36, or 1/12. 5, 4 out of 36, or 1/9. 6, 5 out of 36 will not reduce. 7, 6 out of 36, or 1/6. 8, 5 out of 36. 9 right here was 4 out of 36, or 1/9. Probability of a 10 is 3 out of 36, or 1 out of 12. 11 was 2 out of 36, or 1/18. And then 12, 1 out of 36, which will not reduce.